Right. So I want to start with something that genuinely changed how I'm thinking about AI economics. And I mean that. This isn't just another hot take about whether we're in a bubble or not. It's actually more interesting than that. Ben Thompson published this piece arguing that the entire bubble framework is wrong, not because AI is justified or unjustified, but because the economics have fundamentally shifted in a way that makes the question obsolete. And honestly, I think he might be right.
The agent's argument?
Exactly. So Luma, walk us through why this matters, because I know you've been tracking the agent story for months now.
Right, so the traditional bubble analysis for AI assumed you needed mass consumer adoption. Millions of people paying for ChatGPT subscriptions or whatever. That's the metric everyone was watching. But agents completely changed the equation. One knowledge worker can now direct multiple AI agents doing actual work, not just answering questions, doing multi-hour tasks autonomously. That means the demand driver isn't consumer subscriptions anymore, it's enterprise productivity spend. And companies have always been willing to pay for genuine productivity gains.
Okay, but here's my question. Are agents actually delivering that productivity? Because I've seen a lot of demos that look impressive and then completely fall apart when you try to use them for real work.
That's the exact right skepticism, and Thompson addresses it. He's not saying agents are perfect. He's saying they've crossed a threshold where they're functional enough that enterprises are willing to pay for compute to run them. Claude Code, OpenAI's latest models, they're breaking down problems, calling tools, iterating without constant supervision. Not flawlessly, but reliably enough that the economics work.
So it's not about perfection, it's about whether they're good enough that the ROI justifies the infrastructure spend.
Exactly. And here's what's interesting from a pattern perspective. We've seen this exact dynamic before with cloud computing. Early cloud was slower, less reliable, more expensive than on-premise. But it was good enough that enterprises started shifting workloads anyway. The infrastructure spending that followed wasn't speculative, it was responding to real demand that exceeded supply. Thompson's argument is that we're seeing the same thing now with AI compute.
So the bubble question becomes irrelevant because we're not in speculation territory anymore. We're in actual demand territory. That's a really significant reframing.
Right, but here's where it gets messy. Because at the exact same time, the people building these models are starting to say publicly that scaling isn't the answer anymore. Sam Altman literally said we need architectural breakthroughs beyond just making models bigger. That's a pretty dramatic admission.
Oh, this is the bit that stopped me. Because you're right. On one hand, Thompson's saying the compute demand is real and justified. On the other hand, the researchers are saying the current approach to building better models might be fundamentally limited. Those things sound contradictory, but they're not. Are they, Luma?
No, they're actually compatible. The infrastructure demand is real because current agents are useful enough to justify enterprise spending. But that doesn't mean scaling is the path to the next generation of capabilities. What we're seeing is the industry admitting that bigger models aren't producing proportionally better results anymore. LeCun, Sutskever, even Zuckerberg have all hinted at this. The people who benefit most from the scaling narrative are quietly backing away from it.
So what does that actually mean practically? If scaling isn't the answer, what is?
Nobody knows yet, that's the honest answer. But the shift is towards architectural innovation rather than just adding more parameters, different ways of structuring models, new training paradigms, possibly hybrid approaches that combine multiple techniques. The next phase is going to be more intellectually interesting than just building bigger data centers.
Right. And I actually find that encouraging because it means we're moving past the brute force phase into something more thoughtful. Okay, so let's talk about what happens when agents meet the physical world, because robotics is where this gets properly complicated.
Oh, here we go. Luma's favorite topic.
I knew this was coming.
NVIDIA's GTC keynote just happened. Jensen Huang stood on stage talking about physical AI like it's infrastructure you can deploy today. Not a research project, actual deployable systems. And honestly, the marketing makes it sound like we're about 6 months away from household robots doing our laundry. But the reality is messier, right?
Significantly messier. Look, the demos are impressive, but when you actually dig into what's shipping versus what's being demonstrated, there's a gap. Boston Dynamics Spot costs about £80,000. If you add manipulation capabilities, you're looking at over £130,000. Tesla's Optimus is targeting a lower price point eventually, but we're still talking years away from genuine household utility.
So what's actually working right now? Because I know factories are using robots. Warehouses definitely are. What's the current reality versus the future promise?
Cobots in controlled factory environments, wheeled robots in warehouses doing very specific tasks, and increasingly, teleoperated units where a human in another location is controlling the robot remotely. That's not the end state anyone's aiming for, but it's where the economics currently make sense. The gap between controlled environments and the chaos of a real household is still enormous.
What makes households so much harder? Because I'm genuinely curious about this.
3 things mainly. Grippers are expensive and still not very good at handling the variety of objects in a typical home. Navigation in dynamic environments where furniture moves and people walk around unpredictably is genuinely hard. And safety around humans, especially children, requires a level of reliability that current systems just don't have. You can get away with occasional failures in a warehouse. You absolutely cannot in a living room.
So when NVIDIA talks about physical AI as infrastructure, what they really mean is infrastructure for controlled industrial applications, not your kitchen.
Exactly. And to be fair to them, that's still a massive market. But the household robot dream is further away than the demos suggest.
Okay, but here's what I found actually encouraging in the research. The tools for building robotic systems are getting sharper. There are new utilities for ROS2, which is the robot operating system, making it easier to integrate AI agents into robotics workflows. That infrastructure work is happening quietly, and that feels like the real foundation for whatever comes next.
That's the pattern we keep seeing. The flashy demos get the attention, but the unsexy infrastructure work is where the real value creation happens. Better debugging tools, cleaner integration layers, standardized interfaces. That's what enables the next wave.
Right. And honestly, this applies to AI code as well. Which brings us to something that came up today that I think builders need to hear about: quality gates.
Oh, this piece was genuinely useful. So someone's built a system of 8 nested validation gates that catches bad AI-generated code before it reaches production. And the counterintuitive bit is where they spend their time. 70% of effort goes into writing clear requirements, not reviewing code requirements.
That makes complete sense though, because vague requirements produce code that technically works but completely misses what you actually needed. I see this with clients all the time. The AI does exactly what you asked for, which turns out to be the wrong thing.
It's the precision problem. Humans communicate with context and implied meaning. AI needs explicit specifications, so if you don't invest the time up front clarifying exactly what needs to be built, you end up with technically correct code that solves the wrong problem. The 8 gates are interesting because quality isn't something you check at the end. It's enforced automatically at every stage. Code literally cannot move forward until it passes validation.
And the system learns. When something fails, it becomes permanent institutional knowledge. Next time an agent touches that area of code, it already knows the trap. That's the bit that makes this more than just a checklist.
So practically speaking, if someone's using AI coding tools right now, what's the takeaway? What should they actually do differently?
Spend way more time on requirements than feels natural. Treat them like a contract. Make acceptance criteria specific and testable. No ambiguity. And build validation into every stage of your pipeline, not just at the end. That's the difference between code that kind of works and code that actually works reliably.
And if you're building RAG systems specifically, there's infrastructure news that matters. Someone's building a platform called Clay Plus that makes RAG components independently swappable. Change your chunking strategy without touching application code. Swap embedding models. The clever bit is parallel projections. You can generate a new index with different settings running alongside production. Compare retrieval quality before you commit. No risk, no downtime.
Why does that matter? For people who aren't neck deep in RAG pipelines every day.
Because right now, most teams pick an approach, get it working, and then never iterate because the cost of change is too high. You have to reprocess all your documents, regenerate all your embeddings, start from scratch, basically. So retrieval quality stays mediocre because nobody wants to risk breaking production to experiment. Composable infrastructure removes that friction.
So it's the iteration cost that's been holding RAG quality back, not the technology itself. That's infrastructure thinking applied to what most people treat as plumbing.
Right. And this connects back to the earlier point about agents and infrastructure spend. The reason enterprises are willing to pay for AI compute isn't because the models are perfect. It's because the infrastructure around them is getting good enough that iteration becomes practical. You can actually improve things without rebuilding everything.
Exactly. Okay, so Luma, there were some quantum papers today. What's actually worth paying attention to?
3 papers landed, one on measurement in non-reciprocal systems, basically how to read qubits more reliably without introducing noise, another on causal structure in tensor networks, and the third about noise-resilient quantum autoencoders. What matters practically is these are all pieces of the scaling puzzle. The theory works. Now it's about making systems work in the real world without falling apart the second you introduce actual noise.
So unglamorous infrastructure work again, making things robust rather than just functional.
Every single breakthrough right now is about that gap between works in theory and works reliably in practice. And honestly, that's where we should be focusing attention, not the flashy demos, the boring engineering that makes things actually dependable.
Which brings me back to Thompson's argument about the bubble. Because if you're measuring AI progress by whether the demos are impressive, you're missing the point entirely. The real progress is happening in quality gates, iteration systems, infrastructure that makes experimentation safe. That's what justifies the spending, not the hype, the actual engineering foundation.
Right, and I think that's the through line across everything today. The conversation has shifted from can AI do this to how do we make what AI can do actually reliable and trustworthy and useful in production. That's a much more interesting question, and honestly, a much more valuable one to be solving. What do you think? Are you seeing this shift in your own work? Let us know in the comments below. We'd genuinely love to hear how you're thinking about this.
And if you're building with AI agents, the Quality Gates piece is worth reading in full. We've got the link in the description below.
So here's the thing to remember. We're not in bubble territory anymore because the demand is real, but we're also not in pure scaling territory because the researchers are admitting that bigger isn't always better. What we're entering is the infrastructure phase, where the unsexy engineering work determines who actually ships reliable systems and who just ships impressive demos. And that's where the real separation happens. That's where teams that invest in quality gates and iteration systems and proper governance pull ahead of everyone else. If you want to stay on top of this stuff, Luma lands in your inbox every evening, completely free. Head to luma.marbl.codes to sign up. All the links to today's stories are in the description below. And if you're enjoying these conversations, hit subscribe so you don't miss the next one. We're also building something for AI professionals who want to level up. Atlas AI Talent. It's a curated waitlist for roles that actually matter. If that's interesting, there's a link in the description. Thanks for listening. See you next time.